All right, for the last part of this investigation, we're going to complete the table of values for each function. Now you can throw this equation into Desmos and use that gear to come up with the table of values to fill in your y values here. I'm just going to actually calculate 2 to the negative 1 is a half, or 0.5. 0.5 there. 2 to the 0, anything to the exponent 0 is 1. 2 to the 1 is a 2. 2 squared is 4. 2 cubed, 2 times 2 is 4 times 2 is 8. 2 to the 4 will be a 16. Now we're going to calculate the difference in our y values. So 1 take away 0.5 would be 0.5, and then 2 take away the 1 is 1, and then 4 take away 2 is 2, 8 take away 4 is 4, 16 take away 8 is 8. Now you'll notice these values here are really just these same values happening over and over again. So if I took the differences again of my y values, I'm just going to repeat the values over and over again. So with linear relationships, when you get that first difference in y being constant, you know it's linear. When your second differences in y are constant, then it's quadratic. With exponential functions, they don't have differences that are constant. What they have instead are constant ratios. And to get the ratio, you're going to divide the delta y value by the delta y value above it. So if I take my value of, let me just switch my pen here. If I take the value of 1, my delta y, and divide it by the one above it, the 0.5, 1 divided by 0.5 is 2. And then 2 divided by, I gotta go grab my other pen. There we go. And then 2 divided by 1, so 2 divided by 1 is 2. And then 4 divided by 2 is 2. And 8 divided by 4 is 2. So really, if you think about that, what we're using in our equation is just powers of 2. Every time to get to our next value of y, we're just timesing by 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And we could continue that pattern along here. All right, let's calculate 2 times 3 to the x. Okay, so Bedmus says I have to apply the exponent first, and then I would do multiply second. So I'm going to start with 0, because 0 is easy. 3 to the exponent 0 is a 1, and then 1 times 2 is 2. So that's that vertical stretch by a factor of 2. I'm going to do the positive 1 next. 3 to the 1 is 3 times 2 would be 6. 3 to the 2 would be 9. 9 times 2 is 18. 3 to the 3 is 27. 27 times 2 is 54. And then 3 to the 4 is 81. 81 times 2, 81 would be 162 times 2. All right, 3 to the negative 1 would be a third, times by 2 would be 2/3, or 0.6 repeating. Now, if I do my differences in y, I'm going to work this way. 162 divided by, subtract 54. Let me get my trusty calculator going just so I don't make a mistake on the video. Subtract 54 is 108. So that has a difference, of 108. That was supposed to go in that block. 108. 54 subtract 18, I get 36. 18 divided, subtract 6 would be 12. 6 take away 2 would be 4. And then 2 take away 2/3 is 4/3. So you can see this time these values don't appear because of the vertical stretch by a factor of 2. These are not the same values as what we have here. However, we're going to do a ratio now. We're going to take 108 and divide by 36. Divide by 36. Oh, look at that, I get 3. And then I'm going to do 36 divided by 12. We get 3. 12 divided by 4, we get 3. And then 4 divided by 4/3, that's 3 as well. So you should be noticing the constant ratio here was a 2. That might have something to do with the equation. The constant ratio here is a 3. That might have something to do with the equation. All right, and filling in values for the last one here. I'm going to start at the bottom and work my way back. If I have a half to the exponent of 2, that would be 1/4, because it's a half times a half, which is 1/4, and then 4 times 1/4 would just be a 1. And then a half to the exponent of 1 would be a half. 4 times a half would be a 2. A half to the exponent 0 is a 1. 4 times 1 is 4. A half to the negative 1 would actually be 2 to the positive 1. And then 2 to the positive 1 is 2. 2 times 4 is 8. I think I see a pattern working backwards here. I'm doing 1 times 2 to get 2. 2 times 4 to get, 2 times 2 to get 4. 4 times 2 to get 8. 8 times 2, this will be a 16. And this should be a 32. So if I find my differences in y here, 16 take away 32, that's actually negative 16. 8 take away 16 would be negative 8. 4 take away 8 would be negative 4, a negative 2, and a negative 1. If I do the ratios, negative 8 divided by negative 16 would be a half. Negative 4 divided by negative 8 is positive 1/2. Negative 2 divided by negative 4 is positive 1/2, and a positive 1/2 again. So looking at that ratio, you can see there's a connection between that ratio and what the base of your function actually is. Our y-intercept, actually, y-intercept happens when x equals 0. Here's our y-intercept here. It's a 1. We really have an imaginary 1 multiplying that 2 to the x here. Y-intercept is a 2, initial value. Here's our 2. Y-intercept here is a 4. Our initial value is 4. So hopefully those things are coming together with the equation. I want to summarize some other things here on the bottom of the page. Okay, so to summarize our key information here, the A value, that is your vertical stretch, but it's also your y-intercept, or your initial value for your equation, except if you've got this extra plus q on the end. So that's a vertical stretch by a factor of a. It also represents your y-intercept if q is a 0. Okay, so as long as you don't have a plus q on the end, it will be your y-intercept for that. Your b is the base of your function, and it has some really important things to know about that. So if b is greater than 1, you get exponential growth. It's going to be a growing function. And that is, of course, if your x, this has to be positive x, positive value of an x. You can't have a negative, because then that actually applies the negative exponent rule, which flips it to the other one. If your b is between 0 and 1, you get decay, a decreasing graph. So that's an important piece of information to know. Your q is your horizontal translation up or down. Sorry, your vertical translation. And it affects the horizontal asymptote. That's what I was thinking when I said horizontal. Vertical translation, it changes your horizontal asymptote. Horizontal asymptote. And that's from that y equals 0. It'll be y equals whatever that q value is there. Okay, so that b value is also your ratio from your table of values. So that's your ratio of your delta y's in the table of values. So TOV stands for table of values. So hopefully those are the key ideas that you've gotten out of this little investigation. Exponential functions will always have a constant ratio of your delta y's, your differences in your y's, as opposed to a constant difference. And that's how you know from a table of values if your function is going to be linear, quadratic, or exponential. Good luck working on your homework questions, and as usual, if you have any questions, let me know.